Hello. In this video, we are going to talk about graph databases. Graph databases are one of the critical databases that are used in the industry. Often we only talk about SQL, NoSQL databases, but what are the databases underneath, right? There are various types of database engines which solve different purposes. Today, we are going to start with graph databases, right? We're going to talk about what graph databases are, how it works underneath. We're going to talk about an example with a working example of a social network graph. We're going to talk about various scenarios and also some popular graph databases that are in the market. And also we are going to see what are the applications where graph databases can be used, right? So let's jump straight in. What is a graph database, right? A graph database is a type of a NoSQL database that basically uses graph theory to represent and store data in the form of nodes, edges, and properties, right? Nodes, which basically represent the entities, edges represent the relationship between the nodes, properties are attributes that describe the nodes and the edges, right? So if you think of a graph, so this is what a graph database primarily looks like, right? Where each node is also an entity which has its properties, right? And each of the edges that you see are the relationships between the edges, right? Unlike traditional relational databases that store data in tables, graph databases use nodes, edges, and properties to represent and store the data, right? So properties and attributes that describe the nodes and edges, which can be various use cases, for example, name, dates, ratings, right? So those can be all the properties. Now, how do graph databases differ from other databases, right? So first we have to understand graph database is not, you cannot just pick up a graph database and put it in your application. It is very use case specific and why it differs from the traditional databases. So the first is optimized for querying, right? So graph databases are very optimized for querying, which is basically it has a very high performance and or it is also optimized for navigating relationships between data points, right? Which makes them ideal for applications that involve, complex data relationships, right? Next is highly scalable. So they can store and process huge and humongous large amounts of data without sacrificing performance. So this is because they use a distributed architecture that basically allows the data to be partitioned and processed across multiple nodes, right? Next is schemaless. Graph databases are schemaless, which means that the data model can evolve over time without requiring changes to the underneath database schema, right? This makes it more flexible and also adaptable to changing business needs, right? So it is also very flexible. So now let's take a look at a social network example. How will we represent that when you have to represent that in a graph DB? So a simple social network representation can be like this, where we have three nodes. Nodes are basically people. We have Alice, Bob, and Eve, and each of them, Alice is friends with Bob, and Bob is friends with Eve, right? So to create a node, right? So for example, here we are going to talk about one of the famous and popular graph databases out there, which is Neo4j. And I'll also talk about their various graph databases in the market, but here the example we are going to take is of Neo4j. So to create a node, right, you write a query something like this. You use the create keyword and then basically define a user who has two properties, name and age, right? So name is Alice and age is 30. So you're creating a node. We can also create relationships using the match and create keywords, right? So basically in this query, what we are doing is we are matching Alice and Bob, two users, and we are creating a relationship called friends with between Alice and Bob, right? We can also put additional properties, like for example, if you want to put what was the date when the friendship was established, right? So we can also do that by matching and creating. So if you notice, we are matching Alice and Bob and we are creating a relation friends with additional property of since it is they are friends from 1st January 2022, right? So this is how you build a relationship. Now how do you query? And basically you can repeat this process to create that entire whole social network graph, right? But then let's say if you were to query the social network graph, right? How will you do that? So one of the queries can be like you are matching Alice and you are matching all the friends of Alice. You want to figure out who are all the friends of Alice, right? That's a basic query that can be determined, and that can be figured using the match and return keyword. So here you are basically doing a match of Alice as an user, and you are figuring out who are the friends of Alice, and then printing, basically returning the name and age of all the friends who are friends with Alice, right? There can be other more complex queries, right? For example, let's say if you want to figure out mutual friends, right? So here, for example, we are doing a match between a user A and a user B, and we are seeing who are the mutual friends between user A and user B. So the query that you write is something like this. What it is doing is matching user A and user B with a mutual friend, and the relationship is friends with, right? Where A and B are not the same person, right? So, and then whenever you are getting A and B, you are basically returning their name and B's name. So you're basically returning the names of all the mutual friends, right? So how do they work? So when a query is executed on a graph database, the database traverses the graph to find the relevant data, right? This traversal is often done using graph algorithms, which can efficiently find patterns and relationships in the data, right? So as a result, graph databases are particularly well suited for queries that involve complex relationships and patterns, right? Like for example, social network recommendation engines. And we will talk about various other applications. Under the hood, graph databases often use a combination of indexing and caching techniques, right, to optimize your query performance. Now, if you think of, like for example, Facebook, right, as a social network, there are billions of users that are using Facebook, and there are hundreds and thousands and billions of relationships, right? So if you have to figure out and traverse and create, like say, mutual friends or relations out of that, those are very complex queries, and those just cannot be done using normal query or scanning of databases, right? That is just not possible. So to achieve those with highest performance and improved lower latency, we use graph databases, where basically they also index and cache some of the query keywords and the results to optimize the performance. Now, for example, a database might use a combination of index structures and in-memory caches, right, to speed up the traversal of the graph, right? So, what are the various? We have been talking about obviously social network, but what are the other various applications of GraphDB? And you should also keep this in mind whenever you are giving interviews, because a lot of interview questions and system design questions ask for, whenever you're designing a system, data is obviously one of the most important, and how do you represent, store, and query data is obviously one of the essential parts of that. So don't just always think about SQL or NoSQL databases, but think about very critical aspects of databases and database engines which can work for your use case, where graph is, for example, if you're asked a social network, graph databases are ideal for social network, right? As they follow, they basically allow users to easily navigate and query complex relationships between people and their connections or followers, whoever those are, right? The next application is recommendation engines. So graph databases can be used for recommendation engines by analyzing user behavior and recommending relevant products, services, content based on similar relationships, right? So those kind of patterns can be built for recommendation engines using graph databases, right? Next is knowledge management. Yes, graph databases can be used for knowledge management by organizing and connecting various disparate data sources to create a very unified view of the data, right? So graph databases are very useful for knowledge management. They are very useful for fraud detection, right? Basically, it identifies suspicious patterns and relationships between entities, like for example, fraudulent transactions or fake identities, right? So those are various relationships where you can build and query using graph databases. There are also various other applications, like for example, network grid design. So if you are implementing a network grid, so you have multiple nodes, you have connections between the node, then there is traffic that is flowing, right? So that entire piece, from a global perspective, if you think it is a graph problem, so to speak, and the data representation can be best stored in a graph DB, right? Then there are supply chain nodes and mapping. So whenever you talk about supply chains, you have distributors, sellers, retailers, right, manufacturers, transit people. So there are multiple players in a supply chain, and whenever you are talking about multiple players, they are all connected, and how do these map to each other for the overall supply chain to work? That kind of a problem can also be solved using the data representation, can also be done using graph databases, right? And there are various other applications of graph databases. Now, what are some of the popular graph databases that are there in the market? There are many, but not. You basically have to understand the trade-offs between multiple databases. But some of the popular are, we have already talked about Neo4j, which saw an example. Basically, Neo4j is a native graph database that is optimized for storing and processing graph data, right? So Neo4j is very popular. Next is Amazon Neptune. Amazon Neptune is one of their cloud managed graph database service, and that is basically designed for very high availability and scalability, and it is on AWS Amazon Web Services platform, so it is very highly scalable, right? Next is Microsoft Azure Cosmos DB. Cosmos DB is a globally distributed multimodal database service that supports graph data modeling, right? So Microsoft Azure is also very popular. Then there is Janus Graph, which is an open source distributed graph database that supports basically multiple storage buckets. So that is where that is very critical and useful if you have a use case for that, right? Then there are other databases, popular graph databases also, like for example Nebula Graph. Then there is memgraph, right? So these are some of the popular graph databases in the market. So in conclusion, graph databases are a powerful tool for storing and processing complex data relationships. They offer several advantages over traditional database types, like including scalability, flexibility, performance, right? Whether you are building a social network, a fraud detection system, recommendation engine, like whatever it is, like so supply chain mapping, knowledge management system, like graph databases can help you unblock and basically unlock the power of your data, right? I mean, to truly be able to use and develop your business and scale, graph databases are primarily the types of databases that can solve that problem. So hopefully this was useful. Thanks for watching.